Okay, so next question. We're looking at, again, a series of electrode potentials, and it's asking us to calculate the EMF of a given cell, which is the H2SO3 couple with a relative iron 3 plus couple. And we know that the electrode potential of a cell is equal to the right-hand side subtract the left-hand side value of the cell. And so for this one, the right-hand side is the iron 2 plus couple, which is here at 0.77 volts. And it's going to ask us to subtract the left-hand side one, which is here at 0.17 volts. Now notice we're not changing the sign of this actual voltage. The subtraction does that for us, so we don't have to change the sign and then subtract it further. We just subtract the value as it stands in the table. So that gives us a value of 0.60 volts. We then have to write the equation for the oxidation process, which is occurring in the negative electrode. And this one is the negative electrode, which is the left-hand side of the equation. The left-hand side of the equation is the one where oxidation occurs. And in an oxidation reaction, in this type of situation, these reactions go from right to left. And so the top equation in that table, i.e. the H2SO3 equation, reacts with a water molecule and produces a sulfate ion with the 4 hydrogen ions and the couple of electrons. So it's the reverse of the coupled reduction equation in the table. So moving on to the next one. This is then asking us for the reaction between hydrogen peroxide and then the iodine iodate couple here. So we've got to combine these equations to write an overall equation for the spontaneous cell reaction. So we know that hydrogen peroxide, which is the third one down in the table there, is going to be producing oxygen. So that is the reaction which is going to be going backwards. Hydrogen peroxide is going to react and produce oxygen with a couple of hydrogen ions plus a couple of electrons. And the iodate equation, which is this one, is going to be going forward, and it's going to be 2 iodates plus 12 hydrogen ions plus 10 electrons going to an iodine molecule plus 6 molecules of water. So they're the two equations, two half equations, which are now going in the correct direction for the forward reaction. But what we have to do is balance up the electrons. We've got 10 electrons on the left-hand side, but we've only got 2 electrons on the right-hand side. So what we need to do is multiply that top equation by 5. When we multiply that top equation by 5, we'll end up with the overall equation that we then need. So we'll end up with 5 hydrogen peroxides. We'll have the 2 iodates that we had originally. We'll have the 12 hydrogen ions, and we'll come back to those in a second, plus going to the electrons have now cancelled, going to oxygen, 5 of those, plus 10 hydrogen ions, plus the electrons which have now cancelled, plus the iodine and the 6 waters. As I say, we're going to come back to the hydrogen ions because we've got 12 on one side and 10 on the other side. What we have to do is cancel those down. We don't need them on both sides. So we get rid of these 10, and then we essentially eliminate 10 hydrogen ions there, just to leave us with 2 hydrogen ions as opposed to the original 12 that we had. And then the final question, just quickly, is give one reason why the EMF of the cell changes. The reason being all of these values in the table are standard conditions. So as soon as you turn a cell on, electrons start to move, reactions start to occur, concentrations start to differ, and then as soon as it happens, the EMF changes because you're no longer at standard conditions.